Hello, this is question 7 from the 2020 MAT. Quantiles is a game for a single player. It's played with an inexhaustible supply of tiles, each bearing one of the symbols A, B or C. In each move, the player lays down a row of tiles containing exactly one A and one B, but varying numbers of Cs. The rules are as follows. Player may play the basic rows, which are those two. If the player has already played the rows of the form R, A, S, B and T. Okay, they've replaced the C's with these R, S, T and then X, Y, Z. They may be the same row. Yep, and each one of those letters is a sequence of C's. Then you can add them together. So you're combining the R and the X. Okay, so all of the C's before the A are joined together. Then you get the A, then all the ones between the A and the B, and then all the ones after the B. Okay, that's a join move. The original rows remain and may be used again in a subsequent join move. No other rows may be played. A player attempts to play one row after another so as to finish with a specified goal row. Give 2 examples of rows other than basic rows that may be played in the game. Right, that's just to show that we've got some grasp on what they've given as the rules then. So we can combine these things together. So let's combine these 2 basic rows. So we're going to get all the C's before the A's. So that's 3 of them, C, C, C. Then we get the A. Then the ones between the A and the B. So that's 2 of them. Then the B. And then all the ones after the B, which is 5 of them. 1, 2, 3, 4, 5. But we can also, I'm pretty sure it said you join them to themselves as well. Yes, copies the sequence of those. It's called a join move, and they may be the same row. So we can do, say, the first one twice. So C, C, A, C, C, B, C, 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 C. Right. Part 2. Give 2 examples of rows, each containing exactly one A and one B, that may never be played, and explain why. Right. Well, we've got loads of things we could put down for this. I mean, enormous numbers. Well, we can't have anything shorter than a basic row. So let's start with one of those then. So let's just do C, A, C, B, C. So we can't have that because it's shorter than basic row. So that's one thing. I suppose we could do a join that doesn't actually fit together. Like we could have 2 C's between, 2C, CCA, CCB, CC. I suppose we could put that in because that just isn't a match. We could flip the, what do we have? Exactly one A and one B. We could even flip the B and the A around. So I'll do that one because it's something different to write, isn't it? CB, CA, CC. So it's the first basic row, but I flip the A and the B round. A must be left of B. There we go. But there's an infinite number of things you could put down there. Let's see superscript n denote an unbroken sequence of n tiles, each labelled C. Yes, we have this every year in these sort of questions. Can the goal row C64A, C48B, C112 be achieved? Justify your answer. Okay, so we've got to get up to... So what's happening when we're combining these things? We're starting with a certain number of C's. We have to start with a basic row. So we start 1, 1, 2 or 2, 1, 3. And then we combine these, which means, so when we combine them, everything's a variation of these basic rows. So like these ones that I've created here, 2 examples ago. So adding them together goes 3, 2, 5, which is adding these things together. And if I've done twice the basic row, which was the one that I did here, then that'd be 2, 2, 4, which is again adding it together. So whatever route we take, we're going up in multiples of those. So every join, is that what I called it? Every join move increases the sequences of C's in multiples of these basic rows. So that is 1, 1, 2 or 2, 1, 3. Right, so we're doing a number of those multiples in order to get up to C64, C48, C112. So if we perform, let's say X112 joins and Y213 joins, then we're going to get what we're going to get. So for C64, so that 64 then is going to be equal to every X is taking it up 1, every Y is taking it up 2. So we got that. And then we got 48. The middle ones are just going up by X and Y. And then the last one, which is 112, is going 2X plus 3Y. Okay. So from the first two, we can see then that Y is 16. Y equals 16, which means that X is going to be 32. So does that satisfy the third equation? So 112 equals 64 plus 48, which is fine. So yes, it can be achieved. Can be achieved. Oh, that was a nice little thing to work out. Can the goal row of that be achieved? So that's 128, 48, and 176. Well, no, it can't, because we're not going to be able to get over double the middle number on the first number. And we can see this straight away, actually. I mean, yeah, I mean, this one's, they've given us easy numbers on this, because we'll be saying that 128 is X plus 2Y and 48 is X plus Y. So we've got the 80 is equal to Y, which means that X is just nowhere. X is minus 32. Well, we can't have that. So that's no good. So cannot be achieved. Right, that's good, good, good. New sheets, I think. Part 5, the goal row of that is achievable. Show that it can be reached with 7 join moves. Right, so we've got to get exactly 7. 31, 16. Oh, that's interesting. So we're 1 less than double. So we're doing mostly, because these are our 112s and our 213s. We've got to have just less than double, just a 1 less than double. So we're mostly doing 213s. Is what we're going to want on this, and we're going to have one of the others thrown in. So let's set up a sequence on this then, or do we just do we do the whole thing? So let's try writing it out. So say we add then, so if we've gone 31, 16, 47, that's where we want to end up, and we start at 2, 1, 3. Right, then interesting that they've got 7 here. And we could take that one off straight away. What do they want us to do in the last part of the question? Is this going to be linked to it? In any game, we call a row useless if it repeats an earlier row or is not used in a subsequent join move. Right, it doesn't seem to be. What's the maximum number of join moves in a game that ends with the same values and contains no useless rows? Right, okay, so because it's going to be easier to get the maximum number of join moves than it is to get it to be exactly 7. Because we can, let's take it down that 1. So we can do that, which takes that down to 45. But we're going up in 213s all the time. So we'd have 4, 6, 8, 10, 12, 14, 16. Right, I've not given enough space. Then let's get rid of these 2 rows. 18, 20, 22, 24, 26, 28, 30, and then we're going 31. So that's what we're doing there. These are just going up in ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's fine. And then these ones are just going up in threes until the last one. So 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 47. Right, so that's the slowest we can get there without, because we've used every one of those rows. That is part 6. That is part 6. So how many have we done? We must have done 15, mustn't we, in order to do that? If we've started here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let's change that to a 6 and say we've got 15. What is the maximum number of join moves in a game? Yeah, that contains no useless rows. So how do we turn that into 7 then? So we're starting the same place, I think, and obviously we end in the same place. Can we get our way out of? Well, we're going to have to do that first join there. We need to get to there, but then we've got a choice. We can skip. We could go to 6, or we could skip to 8. That could certainly work, couldn't it? So we've got choices. If we went to 8, then we could do 8 and 8 again, which would go to 16. And then, right, well, we want to get to 30 if we're going to 31. So say we were doing 30. Maybe it'd be better to go 20 and 10. So say we had 20 and 10, and then we could get, so how many would that be? Well, we don't count the first one because that's not a join. We do one join to get there. We get another join. Yeah, we're counting the end point of these. So I'm going to want 8 stars because there's going to be 8 things in the list, 7 joins. So I want 8 stars. At the moment, I've got 6 stars. So I need to do 2 more in order to get to 10. Is that right? So I'd have to have that one and that one. So can I do? Yeah, I can just go 2, 4, 6, 8, 10. Double the 10 up to go to 20. Add the 10 onto the 20 to get to 30, and then add the 1 on. Right, okay. So I just need to rewrite these numbers. I can just rewrite this for part 5. I mean, maybe there's a system for this. I've done this a little bit trial and error. But 2, 4, 6, 8, 10, then 20, then 30, then 31. So that'd be going 1, 2, 3, 4, 5, then 10, then 15, then 16. That'd be 3, 6, 9, 12, 15, then double it to 30, then go to 45, and then add the 2, 47. Right, okay. So yeah, a little bit sort of fiddling around, but it was easier doing part 6 and then going back to part 5 than it was to just go straight in on that 7 joins. But I suppose that's the way you can do it. If you've got the maximum list of all 15, you can just skim out ones that you don't want. And there's probably other ways to get there in 7, or maybe. I mean, if you did especially if you've done 2, 4, 6, 8, if you've done those and go 8 to 16, would that have worked? So if we've gone 8, 16, let's say we've done the first 2, 4, 6, 8. 8 goes to 16. We could go again to 24. Obviously, we've got to have the last one, so that's already 7. So then where do we go from 24 to get to 30? We add the 6 on. So there's loads of different ways you can pick through this. So yeah, 2, 4, 6, 8, 16, 24, 30, 31. That would have worked as well. Right, okay, they didn't ask for all that much in that question, really, but a little bit of fiddling around. It was a bit to get to grips with what the game was actually meant to be. Doesn't sound like the funnest game in the world, but often these ones aren't, do they? But that's wrapped up 2020, Matt, then.